Hi everyone, I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. Today in this class, I would like to complete the overview of second unit. So in the yesterday's class, we have discussed about the uh, starting of the unit 2, that is first part of the overview of unit 2, and this is the second part. So we have seen about the classification and what is a polymer and the classification of polymer and different molecular chain configurations and thermosetting plastics and thermoplastics and types of the thermoplastics also. We have seen about the comparison of three different polymer categories and difference between the thermoplastics and thermosettings and desired properties and functions of a matrix and different behaviors of these polymer matrices, that is stress strain behavior, effect of temperature, and etc. So these are different settings, and we have seen about the thermo settings plastics also. So we have seen of the role of matrix. So what is the purpose of a matrix on the composite materials and desired properties of a matrix. So today we are going to see about the what are the metal matrix composites. So we have seen about the metal matrix composite in the earlier classes. So these metal matrix composite is a composite material with at least two constituent phases or parts, one being a pure metal. So one being a pure metal necessarily. The other material may be different material or another metal. So this is the required one for the metal matrix composite. So these should be such as ceramics or organic compounds also. So we can either mix the ceramic compounds or organic compounds. So we have seen the history also. So what is the initial work done on the metal matrix composites? So it has started in the early 1960s, which was stimulated by the high performance needs to be the aerospace industry. And first of all, they have seen the steel wire reinforced copper, which were among the first continuous fiber reinforcement metal composites, and then they have come from the boron filament, which was the first high strength and high modulus reinforcement in the metal matrix composite. So this is the first reinforcement in the metal matrix composite. So why we are using the metal matrix composite? So we are using these metal matrix composites because of the higher strength involved in it and high stiffness. It also has the following properties derived in it. And it has good wear resistance and damping capacity and specific modulus. So these are the different properties of the metal matrix composite. Next, coming to the classification, it has been divided into 4 types. First one is the dispersion hardened and particle composite. Second one is the layer composite, fiber composite, and last one is the infiltration composites. So these reinforcements have been added in the like the monofilaments. So you can see it in the picture. This is the monofilaments, which is like a reusable battery. And second type is the whiskers or short fibers. So they have been used in the form of a whiskers. And last one is the particles, a small powder type particles seen in the material. So these are the different types of classification of MMCs. Next, composition. So what is the general composition of the metal matrix composites? So we have seen there different types of metal compositions: graphite, boron, aluminum, and silicon carbide. So each have a different matrix. So first of all, we see the graphite. So it has the aluminum, magnesium, lead, and copper matrix. And second one is the boron, which has the aluminum, magnesium, and a titanium matrix. And third one is the alumina, which is has the matrix aluminum, lead, and magnesium. And next one is the silicon carbide, so which has the matrix of aluminum, titanium, and super alloy. Next is the reinforcement. So in the reinforcement, the reinforcement is directly embedded into the matrix, and it changes the physical properties, wear resistance, friction coefficient, and thermal conductivity of the matrix. So the reinforcement should be continuous or discontinuous. So we can use it in the both ways, either it in the continuous way or discontinuous way. So then we have seen about the processing of metal matrix composite. So in the processing of metal matrix composite, we have the continuous fibers. So this is applied by the coating, and then it is drawn through the melt and slurry of the plasma spray. So these are all the different types of processing methods of the metal matrix composites. So first one is the hot pressing method. Second one is the diffusion method, and third one is the diffusion method with hot press. That is, alternate layer of fibers is added and matrix is added in between that. That is of powder type. And second one is the sheet type. And third one is the solidifying method. And for last one is the solidifying in the unidirectionally way. So these are the different types of processing methods used in the metal matrix composites. Next, manufacturing and forming methods. So there are different types of manufacturing and forming methods for the metal matrix composites. First one is the solid state methods. Second one semi-solid state methods. Third one is the liquid state methods. Fourth one is the vapor deposition. Last one is the in situ fabrication techniques. So these are all the different manufacturing and forming methods. So coming to the first one, solid state methods. It has the powder metallurgy method, which the powder is processed of blended fine powdered materials, which is pressed them into a desired shape, that is called as compaction, and then heat is applied on the compressed material in a controlled atmosphere. So that is called as sintering. So after the two processes, it is called as powder metallurgy. Next one is the foil diffusion method. In the foil diffusion method, a thin layers of different types of fibers and metal foils have been put it in the layer by layer method and pressure is applied on it. So this is called as diffusion bonding. Third one is the semi-solid powder processing methods. So in this method, the bulk material is then refined into a microstructure. So that is called as microstructure refinement, and this is compacted into a powder-like structure, that is called as pre-compacting. Then it is sent to the semi-solid forming with the bulk materials, and finally it is sent to the forming one, that is called as semi-solid powder processing. Next one is the liquid state methods. First one in the liquid state methods, first one is the squeeze casting method. So in the squeeze casting, a open mold is created, closed mold is taken, and the molten metal is poured in the die, and when the molten metal is poured and fixed in the lower fixed mold half, then the upper mold movable mold half is closed into the lower fixed mold half, and then the curing is done in the preforms. The ejector pin is ejected and the mold is released from the die. So that is the method in the squeeze castings. And next one is the electroplating and electroforming process. Here we can see that we used the nickel metal and a mandrel, which electroforms the electrodeposition process through the electrolytic solution. Next, third one is the stir casting method. So the stir casting method is very highly used in the research purpose and in the industrial areas also. So there is a furnace and we put a crucible and some solid pieces in the crucible in the furnace. So the crucible is directly placed in the furnace and we use it to liquidify the metal, by raising the temperatures in the furnace. Then a stirrer is added in the crucible to stir the molten metal, and the stirrer screw is stirred when the reinforcement is added to it. So when the reinforcement is added to it, the stirrer screw is stirred through it. And the electric motor is used to stir the screw. So this stirrer is used to combine all the reinforcement particles throughout the molten metal, that is no not creating the voids or any other sections. And this stirrer blade is made with the graphite material, and also the crucible is also with the graphite material only. So this is about the stir casting technique. Next one is the pressure infiltration method. So in the gas pressure, there it consists of two types. First one is the gas pressure infiltration. Second one is the pressure dry infiltration. So in the gas pressure infiltration, a preform is already designed like as a mold, and then the molten metal is poured into the preform. Then this pressurized gas is imposed through the pipe, in which the molten metal is completely sectioned into the preform. So this is called as composite. And then the pressure dry infiltration is has a molten metal directly sent into the pressure chamber and then to the screw to form the preforms. Then the cover die is used to cover the section of the mold, and the ejector die is used to remove the mold from the die through the ejector pins. So these are the two types of pressure infiltration methods. Fifth one is the spray deposition. In the spray deposition, the molten metal is directly pumped into the cold wall crucible through the induction coils, and then it is opened through the nozzle, and it is sent to the atomizer and scanner. Then it is sprayed from the atomized spray, which is sprayed by the spray deposit to the heated substrate. So the heated substrate element is moved to moved on the sideways, that is on the right side and the left side. You can see it in the picture. Argon gas is used to control the pressure in the vacuum. Next one is the vapor deposition technique. So in the vapor deposition technique, the input is from the shielded RF power, which has an electrode in it, and the silicon wafers is melting through it, and the heater is attached in it. And this air surface is sent from the vacuum pump and exhaust, and it is sent to the magnetic drive, and it is controlled by the magnetic drive sections. And last one is the in situ fabrication technique. So in the in situ fabrication technique, the molten alloy is directly sent from the unidirectional solidified MMCs. And what are the different applications of MMC? So they can use it in the driven shaft materials, and the materials used in the driven shaft is aluminum, magnesium, silicon, copper, and 20% of aluminum oxide. So that is 80% of composition of the aluminum, magnesium, silicon, and copper, and 20% is added as aluminum oxide. The processing techniques used for the driven shaft applications for MMC is extrusion from the cast feeded material. Second one is the car disc brake. So they can also use it in the car disc brakes models also. So the processing used for the car disc brakes is sand or die casting. So the materials used is aluminum, silicon, and magnesium with 80% and 20% is volume of silicon and copper. So 20% of the silicon copper material. Next one is the long tunnel bracing beams for planes. So there are long tunnel bracing beams for using the production of planes. So there we can also use the this type. So the material used is aluminum, copper and magnesium, and 50% volume of copper. So 15% of copper is extensively used. So you can see the beams here. This is a long bracing beams which is used to manufacturing of planes. So the process used for these bracing beams for planes is extrusion or forging of casted feed material. So highly they are using these extrusion process only, not using the any type. Next application is the disc brake calipers for the passenger cars. So in the passenger cars also we use to manufacture the disc brake calipers with the help of metal matrix composite, and they are used with the material aluminum alloy with Nextel ceramic fiber, and 55% of the cast iron is used for the weight reduction process only. So they are highly used in the weight reduction process of the cast irons. Next, they can also be used in the particle short fibers reinforced light metal diesel pistons. So in the manufacturing of the diesel pistons also these metal matrix composites can be used. And in the defense also tank armors has been manufactured by these metal matrix composite only. Steel reinforced with boron nitride have been heavily used. So next, this Honda company has using the aluminum metal matrix composite cylinder liners in some of their engines, including the B21A1 and H222A. So these are the different types of cylinder models in the Honda company. So they are using also the aluminum metal matrix composite. And next one, Toyota has using this metal matrix composite in the Yamaha designed 2ZZZ engine. So basically Yamaha is manufacturing this ZZ engine, and Toyota is using it in their cars. So this is also one of the application. And next one, it comes the F-16 Flight Falcon, which uses the monofilament silicon carbide fibers with the titanium matrix in the structural components in the jet's landing gear. So you can see the jet's landing gear here. So they are also made with the metal matrix composites only. And next, this 12 mid fuselage structure of space shuttle orbit also used with these boron aluminum fibers only, that is called boron aluminum tubes. So they also manufacture. They are used to manufacture the space shuttles, that is rockets and other space shuttle programs. And next, aluminum high gain antenna waveguides or boom for the Hubble Space Telescope. So this Hubble Space Telescope is also used in the aluminum high gain gauge antenna. And next is the what are the demands of the metal matrix composite. So what is the basic demands? So first one is the low density. So you use it to reduce the weight of the metal matrix composite. Next one, mechanical compatibility. So mechanical compatibility means we use it to find the mechanical properties desired in it. Next one is the chemical compatibility, thermal stability, and different properties, that is economic efficiency, good process ability, high compression temperature. So these are all the desired demands in the metal matrix composites. So there comes the good processability, economic efficiency, and high compression tensile strength properties of a metal matrix composite. So then we can see the mechanical properties. So desired mechanical properties which comes with the different metals. Here in the graph we can see the magnesium aluminum oxide, and aluminum silicon carbide. So these are all the different mechanical properties of metal matrix composite. And strength of the MMC. So what are the volume reinforcement of the metal matrix composites? Next, we can see the Young's modulus comparing with the different metal matrix composites, that is the particles, whiskers, and discontinuous fibers, with the long and continuous fibers. So generally, these long and continuous fibers have good Young's modulus, that is very high gigapascals, with compared to the particles, whiskers, and discontinuous fibers. Next one is the advantages. So advantages of these metal matrix composites. So different advantages have been seen. That is, casting is very low in structure and no moisture absorption, fire resistance. So these are all some of the advantages. And here comes some disadvantages also. These fabrication processes are very complex and expensive. So some of these metal matrix composites have been very expensive, and the fabrication process is also complex, and machining is very difficult, that to a normal labor. So some skilled labor have been equipped to do this, and the fiber matrix interactions at high temperatures degrades the fibers, so that degrades the fibers also. Next, future plans and applications. So what are the future extensions of these metal matrix composites? So it can be used in the aerospace and army defense, and ERTI offers excellent values of these absolute strength and stiffness. So when you have to need the absolute strength and stiffness, you use it to uh, find the metal matrix composites only. Next, discontinuously reinforced metals, and which affects the decreasing of the cost, and more mature production systems. So these are all the different features and applications of the metal matrix composites. So by here we have ended the second unit and overview of the second unit. Thank you.